Hi all, welcome to my channel. Today we will discuss about a single phase induction motor types and the working and its applications also. On completion of this session you could able to know what is a how many types of single phase induction motors are available and how they are working and what are the application generally where it is applied. So here we are going to see about the capacitor start motor and the split phase induction motor and its main components, working principle and applications, and even torque and slip characteristics. So the requirement for producing a rotating magnetic field. So we have already discussed in a three-phase induction motor that how a rotating magnetic field have been produced, and only due to the rotating magnetic field the motor is getting self-started. So we have analyzed that in a previous class that single phase induction motor is not a self-starting motor. For making it as a self-starting motor, we have splitted a phase into two phases. So by two phases, we have got a rotating magnetic field. So we achieved a rotating magnetic field. Hence, after the moment, the motor is a self-starting. So the requirements are that for producing rotating magnetic field, two things are essential. There must be two windings and they must have space displacement and also phase displacement of 90 degrees so that it will form a rotating magnetic field. You can see this animation. So by the two magnetic fields, you could able to see the resultant magnetic field which is rotating. So now we will see the classifications of a single phase induction motor. So how many types of the induction motors are available? According to the methods of starting, there are almost five methods or five types of induction motors. Okay, so resistance split phase motor or split phase motor, capacitor start motor, capacitor motor, capacitor start and capacitor run motor, and shaded pole motor. So the capacitor motor is a combination of both. Okay, so we are going to see split phase capacitor start and run, and shaded pole induction motors. So here in a split phase motor, the stator carries two windings. That is, the first one is main winding and the second one is auxiliary winding. That is also called as starting winding. For starting purpose we are using. And these two windings are displaced in space of 90 degrees. And the rotor is mostly squirrel cage type. So if you see here, there are two windings parallelly connected to each other, and the blue color is indicating a starting winding, and here it is a running winding that is called main winding, and starting winding is called auxiliary winding. So there is a switch, and this is a squirrel cage rotor. It is supplied to an AC. Okay, so this is a split phase motor resistance start. Okay, and there is another picture. If you see, there is a capacitor. This is a split phase motor capacitor start. Okay, so we know the already we discussed about the rotor which is available in a single phase induction motor is a squirrel cage. So this is a motor. This is a rotor. So you can see the picture also. Even you can observe the screen how nicely it is visible. So this is a resistance start split phase motor. split phase motor having 4 terminals. So this is a phasor diagram, resistance split phase motor, phasor diagram. Generally it is called as split phase motor. Okay. So see here, this is a running winding and starting winding. The current which is passing through the starting winding is I start, and the current which is passing through the running winding, and that is the main winding, is I run. There is a switch, and IT is the total current. So in this vector diagram, so I start with certain angle, and this will be I run. In I start, I mean at the starting current, for starting current, I mean for starting winding, there will be more resistance in an auxiliary winding and more reactance in an running winding. So according to that, so this angle will be near to the V component, okay, voltage. So I start will be near to the V, and I R will be much away due to the reactance component is more. Okay, so the combination, these two summation is IT, and this is an angle phi. So you can see this, the components IT is resolved, the total actual current, the two components it has been resolved, that is IR and IX. Okay. Resistance, a split phase motor, that for getting space displacement and starting winding is designed as high resistive and main winding is reactive. That is what we have seen in the vector diagram, which the component which is near to IR is in high resistive, and the component which is nearer to IX is reactive. The main winding current is iron, and iron lags V by nearly 90 degrees if you observe in the vector diagram. And starting winding current is I start, and running winding current is iron. I start is almost in phase with VT. So iron and I start produces two fluxes. So there is two currents now, it will produces two fluxes, and they should have a phase displacement of nearly 90 degrees for ideal split phase motor, but the angle is in between 20 to 30 degrees. So we know, we have studied the double field magnetic uh, field theory. So in that we know that if the two currents should have 90 degrees. So according to the concept, ideally it should be 90 degrees, but in split phase, the the angle between the two currents is 20 to 30 degrees. So this condition of space and phase displacements are achieved. For rotating magnetic field is produced, and the motor develops torque like this. Okay. So we will see the working principle of a split phase induction motor. The auxiliary winding is not designed for continuous operation. Okay. So single phase given to the motor, and when the rotor picks up the speed, auxiliary winding is automatically disconnected by the centrifugal switch. So to prevent the motor drawing excessive currents, to protect the motor winding from overheating. That is why this auxiliary winding is called starting winding. Only while the start time we are using the auxiliary winding. After a pickupping of some speed, we will only run with the running winding, that is a main winding. Okay. The reversal of rotation. How it is possible for the reversal of rotation? It can be obtained by reversing either the main winding terminals or else the auxiliary winding terminals. Okay. So we will see the advantages. What are the advantages? Advantages are they can be operated at nearly constant speed and it can be reversible at low speed and rapid accelerations can be achieved and it is a low cost. So what are the disadvantages? Disadvantages are repeated start and stop cycles heats the winding and less useful for large inertial loads. So we have seen advantages and disadvantages. What might be the applications? We'll see even that. Okay. So these split phase induction motors are used in fans, blowers, washing machines, oil burners, electric tools, etc. Okay. So now we will see about the capacitor start motor. So this is a split phase motor, centrifugal switch. You see, and there is another switch, another winding. So this winding is the black dark color winding is an auxiliary winding. Okay. Okay, the capacitor start single phase induction motor. It is also known as a capacitor start induction run motor. Okay. So this is a capacitor start motor. So this is a starting winding, running winding. What we are using? We are using one capacitor in series with the starting winding and there is a centrifugal switch. So we are using this capacitor only in the starting time. Okay. So the capacitor start induction motor, the capacitor is connected in series with the starting winding. And by choosing proper capacitor value, starting winding current IST at standstill can be made to lead main winding current, that is IM by 90 degrees, that is main winding current. So how the construction will be? The capacitor usually mounted in a metal casing on the top of the motor. In some cases, capacitor is mounted inside the motor housing. So the capacitor used is an electrolytic type and it is designed for very short services. Okay, I mean duty services. So the size of the capacitor depends upon rating of the machine and it is around 50 microfarads to few hundred microfarads and it finds application where high starting torque is essential. So where it will be mostly used, where there is a high starting torque, there it will be used. And centrifugal switch is disconnected when the capacitor picks up speed. Means even a capacitor also will disconnect. Okay. So because of the short duty services of the electrolytic capacitor, proper operation of centrifugal switch is important. So the main and starting windings are space displaced by 90 degrees and the time displacement is achieved by a capacitor in series with the starting winding. So we know that in a vector diagram, if we observe in a previous split phase, so IM, that is a main uh, current, lags voltage by pi maximum, that is pi m, sorry, the angle pi m. Okay, and IST leads V by pi st. So the angle between IM and IST begins, which is nearly 90 degrees. So the phase displacement is achieved. So the motor develops high starting torque. So due to actually what we have seen in a split phase induction motor, that is only 20 to 30 degrees time space displacement, that is an angle is forming, but whereas in a capacitor start the larger the angle has been formed. Okay, so when the single phase supply given to the motor pickups speed up to 80 percentage rated speed, and the capacitor in the circuit only during the starting period. So when the motor picks its speed, the capacitor and the starting windings are automatically disconnected by the centrifugal switch. Okay, and the capacitor can be selected as per the requirement of starting torque, and it can as high as 350 to 400 percentage of full load torque. So the torque speed characteristics is as shown here. So this is a torque and speed characteristics of a capacitor start. This 0 and this is an ns. Here, if for example if we use only main winding, okay, so we know that if we use only main winding, what happens? Only one winding, there will be no torque developed. So 0. Okay. So here we are adding an external winding, that is auxiliary winding. So after adding an auxiliary winding, what happening? And with the capacitor, so the starting torque is here nearly 300 to 400 times of the actual. Okay. So here, then what happening from here? And here we are using only the main winding. After 80 percentage of speed reached, then centrifugal switch will be off, and here will only the main winding curve will work. Okay. So the capacitor start induction motor is a diagram. See, we have already discussed. Okay, so IM, that is main field winding, is lagging by pi m, whereas IST is leading by pi st. Okay, so total displacement, that angle between the IST and the IM is alpha, which is almost 90 degrees. So how the capacitor start motor will reverse? It can be done by reversing the main field or an auxiliary field winding for a starting any terminal. So here the summary is that the capacitor motor is one of the split phase motor, and this the phase shift is obtained by a capacitor in series with the starting winding. No centrifugal switch, so no the capacitor in this. So the capacitor start motor is one of the split phase. The phase split is obtained by capacitor in series with the starting winding, and the capacitor and the starting windings are cut out of the circuit when the motor picks up its speed, and it is suitable for very high torque applications. We have seen after adding the capacitor how the angle between the both the currents has been increased so that the torque is increased. Okay, so in a ceiling fan employed permanent capacitor motor, secondary winding surrounds the, so there is a capacitor uh, which is permanently in the circuit. That means even in running condition it will be available, and in the starting condition it will be available. So we have discussed that there are nearly 4 to 5 types of induction motors. Okay, so there is a capacitor motor, only capacitor motor, which is called a permanent capacitor motor. So it is the only the capacitor, it can be used in starting and also running condition. Okay. So here the question is that in a ceiling fan employing permanent capacitor rotor, A. The secondary winding surrounds the primary winding. Secondary winding runs secondary winding surrounds the primary winding. Okay. So in comparison to the resistance start induction motor, the permanent capacitor start is more expensive or has better power factor or has better starting torque. It is all of the above. Okay. In comparison of capacitor start, capacitor run, we have not seen this, but quizzes is there. Okay, fine. So we can see this all fine. We will. There is nothing wrong in seeing the multiple choice questions without covering. But anyhow, we will cover this session in the. I mean, in next session. Okay. But you just go through it so that you could able to understand easily the point. Okay. Anyhow, if you get a doubt, we can discuss in the next session. So in comparison to capacitor start, capacitor run, it is simple and low cost, poor power factor and poor starting torque. So which of the following statement regarding permanent capacitor motor is false? It does not have a starting winding and a squirrel cage rotor. Okay. So it is having a starting winding. Squirrel cage motor also it will be there. It does not have a centrifugal switch. This is okay. It's false they asked. So permanent magnet, so it really do not have a switch. Okay. It's auxiliary winding designed for continuous rating and it is more sensitive to voltage variation during to its poor running torque. All are true. Only this is false. In a capacitor start induction motor, capacitor is connected through a switch. Yes, it is in series with the winding, auxiliary winding. Okay. A capacitor selected for capacitor start motor should be rated for any capacitor. Okay, it should be rated for peak voltage. The capacitor employed in a capacitor start motor, no polarity marking. The value of capacitor of a capacitor start motor is determined by its starting torque because for starting only we are using. Okay. In a capacitor start induction motor, capacitor is connected through in series with an auxiliary winding. Capacitor in a single phase induction motor, it will improve the power factor, it will improve the starting torque, starting the motor, reducing the, it will starting the motor. In a capacitor start one phase induction, single phase induction motor, the current in an auxiliary winding lags the current Im in a main winding. It is in phase with Im. It leads the Im by 90 degrees. It leads Im by almost 80 degrees. Okay. Single phase induction motor can be reversed by interchanging either supply, either starting winding or auxiliary winding. Okay. In the capacitor of a capacitor start motor fails to open when it picks up speed, the capacitor will get damaged. Compared to resistor split phase motor, a capacitor start motor has high starting torque, obviously. Okay. A capacitor start induction motor is switched on to a supply with its capacitor replaced by an induction of an equivalent reactance, then not start at all. So there will be a formation of an angle. So it won't start, okay? If the capacitor of a capacitor start induction motor is short circuited, then the motor also does not start, okay? If the capacitor of a capacitor start induction motor fails to open and picks up the speed, the capacitor will get damaged. Single phase induction motors are made up of made self-started by using auxiliary winding, using an external device, increasing rotor resistance, any of the above. Using auxiliary winding. Using auxiliary winding. The two windings, main winding and auxiliary windings are connected in parallel. The stator winding of single phase induction motor is splitted into two parts. Okay, improving efficiency, improving power factor, develop starting torque. Okay, when single phase induction motor picks up speed, which winding is cut off? Auxiliary winding. In a split phase motor, the ratio of number of turns on auxiliary winding to that on main winding. So it is less than 1. The torque speed characteristics of two-phase induction motor is largely affected by X by R ratio. Split-phase motors are seldom used in size larger than 1 by 4 kilowatts. Single-phase induction motors are classified based upon starting methods, both even construction starting methods. A rotating magnetic field is produced by current in the two windings displaced by 90 degrees. This is the principle of phase splitting. When a single phase induction motor picks up speed, its starting winding is disconnected and the motor running on main winding. In case of split phase, the phase shift between currents in a two winding is around 30 degrees. The main winding of split phase induction motor has high reactance. Okay, in auxiliary winding, it is resistance. Second one is auxiliary winding, it is resistance. Main winding, it is reactance. For ideal split phase induction motor, the angle between the main winding current and auxiliary winding current, it should be always 90 degrees. The stator of a split phase induction motor carries only one winding? No, false. It has two windings. A single phase motor has no starting current of its own. Yes, that is true. A split phase induction motor, the auxiliary winding has a lower resistance to reactance ratio. False. It has resistance high. Okay. A split phasing in a split phase motor is done by no transformer, no. In case of single phase induction motor, inductance may be used in series with the main winding. False. So as if now we have discussed about two types of induction motors, that is split phase and a capacitor start induction motor, their applications and the working principle and the speed torque characteristics also. So in the next session, we will discuss about a capacitor start and run induction motor and shaded pole induction motor, its working principle and applications. So hope you have understood this session, and the basic requirement is that the two currents, auxiliary current and the main current, should the angle should be produced 90 nearly 90 degrees to have better torque. Okay, so if the angle between these two currents is less, then the torque will be less. If it is achieved high, then it is the torque will be high, and it should be 90 degrees. The ideal should be 90 degrees. So agenda is that we have to uh, bring the angle nearly to the 90 degrees without affecting any performance. Okay, so likewise in the starting methods, we have split phase and capacitor start we have discussed, and in the next session we will see the another two. So hope you have understood this session. Thank you so much for listening this session. We will meet in the next session. Thank you.